Hi, I'm Paul, and we're doing Leetcode must know interview questions. Today's challenge is word ladder. Um, a transformation sequence from word, begin word, to word, end word using a dictionary word list is a sequence of words, begin word to S1, S2, and so on up to SK, such that every adjacent pair of words differs by a single letter. Every S sub I for I between 1 and K is in word list. Begin word does not need to be in word list. And S sub K equals end word. All right, let's look at the whole method here. So the input is a string, that's the begin word, a string, that's the end word, and a list of strings, which is the words that we're allowed to use in the transformation from begin word to end word. You've probably seen, puzzles like this where you start with a word and they give you a start word, they give you an end word, and then a series of blanks, and you go down and change one letter at a time, transform the begin word to the end word. That's what we're going to do here. Okay, let me move this back. All right, return the number of words in the shortest transformation sequence from begin word to end word, or 0 if there is no such sequence. So we got a couple of examples. Example 2 is just an example of where it doesn't work and you return 0 because the end word is not in the word list. But let's say all of the words that we need are in the word list. We're going to go from hit to cog. How do we do that? We can use hit, we can use hot, that's in the list. We can use dot, that's in the list. We can use dog, and we can use cog. Also notice that they don't want the number of steps that it took, which would be 1, 2, 3, 4. They want the number of words. So the first word counts as a word. Okay, other constraints. The word length will be somewhere between 1 and 10. End word and begin word are the same length. The word list will contain between 1 and 5,000 words. And every word in the word list will also be the same length as the begin word. It's all lowercase letters. Begin word does not equal end word, and all the words in the word list are unique. Okay. I already recorded a solution to this. And when I did that, I said, this is exactly like the last one we did, which was the minimum genetic mutation, where you're given a start gene and an end gene, and you transform it a gene sequence. Here, let me bring it back over here. A gene sequence, and you transform it from the start gene to the end gene using the words in the word bank. Change one letter at a time, and return the number of steps. And I don't remember. I guess we can resubmit it here and see. But this ran pretty quickly. Like 0 milliseconds. We're in the vanguard here. It beats everybody. Well, not everybody, but it's at least as good as 100% of the submissions. It rounds to 0. Now, the next thing I did was to say, I'm just going to copy this. I'm just going to copy this and use it with some small modifications as the solution to word ladder. So why is word ladder hard? And the other one is medium if the solution is the same. And when I ran it, I saw the fastest solutions came in around 11 milliseconds. My solution came in at like 698 milliseconds. So pretty bad. And I see what the problem is, and that is, I think I mentioned this when I recorded the first one, the genetic mutation is, you could also, instead of just comparing words and seeing, if they differ in only one letter, you could just change each letter in the gene sequence one at a time and see if you match something in the word bank. And that seemed less efficient to me. So I didn't do that. I just compared I just compared the words. But you see, here's I realized afterwards what the problem is, and that's why I'm re-recording it, and that is that the gene bank only has a length of 10. There's only there can only be 10 gene sequences to work with. Now the word ladder has 5,000 words. So if each word can only be at most 10 letters, and we have 26 letters, even if you had to go through all 26 letters 10 times, it's still 260. It's a lot less than 5,000. That's the problem. So I'm going through this 5,000 word list, and I think that's what slowed it down. So anyway, I'm going to try this again. I'm still going to try pasting this in, but I'm going to make more modifications to it. So we start out with a Q, and let's see. We start out with a Q, and we put the start word in the queue, right? That should work. I wonder. Let me think about this. Let me think about this for a second. Okay, there's a couple of ways to handle this visited set. One is that we can add a word to the set when we use it. Another is we can put all the words in the set and take a word out when we use it. And I think the access time is going to be a lot faster if we put the words in the set and take them out. Look for them in the set and take them out. So we're gonna do it that way. But now it doesn't make sense to call it visited. So let's just call it words, and we will create a set of the word list, and then we don't need that. We already called that words. Should be a good thing to call words, but let's just call it result equals. Let's set it to 1 because the first word counts as 1, as opposed to the previous one, the minimum genetic mutation, where they wanted the number of steps. In this one, they want the number of words. All right, so while the queue is not empty, we will, somewhere in here, we've got to increment the results. I'm not sure if it matters. I'm going to leave it the way it is for now and just say that okay, we're going to go through the queue. We are going to get string, not a gene, but let's say string S. No, string S is we'll dequeue the string, And we are going to, strings are immutable, but if we convert it to a character array, then we can do some surgery on it. To char array. All right. We need to check that, but not yet. Well, let me leave it here for now. Actually, let me put it down so it's out of the way. All right. To char array. And now we need a nested loop. All right, so that's the nested loop. Yeah, let me move this up, but we're gonna have to change it. Okay, I'm gonna take that. I'm gonna put it up here as a nested loop, but we need an index here because we're not doing an iteration through every word in the word list. We're going to change characters one at a time. So let's say for int j equals 0, j is less than chars dot length, j plus plus. We're gonna have to save this. It's possible that there's more than one word in the word list that is one letter removed from the word that we're currently considering. So we are going to, before we change a letter, we're going to save it so we can put it back and then see if there are any more words that are one letter removed. So char ch equals chars j. And yeah, we need another loop here, but we can't use j now. Let's say for int, no. Say for char k equals a, k less than or equal to z, k plus plus. And we'll substitute the letter. Chars j equals k. Okay. Now, in order to look in the set, which is a set of strings, we're going to have to change this back to a string. So let's say string, can we call it string, S2, I can't think of a good name for it. S2 equals new string, and we'll feed in the character array. All right. If, let's see, we don't need that. If words, that is the set of words, if words, well, actually, let's do it like this. If words does not contain S2, then we're going to keep going. We didn't match it, so, we'll try the next letter. Okay? If we get past that, that means we did find the word in the set of words. So the first thing we want to do is check and see if, what is it called? It's end word, right? End word. If end word equals S2, that means we found it. Then return return, what did I call it? Result. Okay, return result. Now I'm seeing that result is going to be in the wrong place. All right. If we return it there, then we're going to be one short. Let's say we find it on the first try. But even if we find it on the first try, result is not 1 because we were counting the words. So we're going to have to move this increment. We are going to have to move this increment up to here. All right. Okay, so we go through each character. We change. Oh no, we don't need C equals 2 either. Char. Okay, and then for char K. Okay, we go through all the letters, change it, see if we can find it in the words. Otherwise, continue. If we find it, check and see if it is the end word. If it's not the end word, then we want to do this stuff. If it's not the end word, we want to do Q offer S2, and we're not adding this time. We are doing words dot remove. We'll remove S2. All right. All right. So we saved this. We saved chars J in CH, and now we have to put it back. Chars J equals CH, because there may be more than one word in here that is one letter removed from the word that we're considering. All right, and we don't need that. And we don't need, well, we actually did this in a different way. Don't need that. And return, this one asks us to return 0. All right. We'll go through this one more time. Okay, we got the Q. We put the first word in the Q. We have a set of words. We have result, which we initialize to 1. And for each element in the Q, we will dequeue it, convert it to an array, increment, result, and then for each letter in the word, we will iterate through all the letters A to Z, change the character to the new letter, and convert it to a string, see if it is in the words set. If it's not, keep going. Try the next letter. If it does match, check and see if it's the end word. If it's not the end word, put it in the queue. That's how breadth first search works. And take it out of the words set. Reset chars J. I think this is actually okay. All right, now the time to beat on this, well, actually, let's just run it first and see if it even does anything. Okay, line 18, forgot a semicolon. Okay. Try it again. Wrong answer. What is the wrong answer? Oh, it says 6. It says 6, and I put 5. All right. All right. Let me reflect on that for a minute. All right. Let's try this. I don't think I want that result increment in that loop. So let's take it out and put it here. All right. I run it again. All right, that's accepted. Just for reference, the time to beat here is 698 milliseconds, which is what I got on the first solution. And submit. Oh, it's a lot better. Like an order of magnitude better. Yeah, so that's pretty good. That's okay. Yeah, that's good. As I said, the last one was 698 milliseconds, which was like sitting way out here somewhere. Again, the problem is this the last one that I did? You know what? That is the last one that I did. Oh, actually, it says 683 milliseconds. But, oh, actually, that's someone else's solution. I don't know what that is. Code sample. Okay. So yeah, so this is a much better solution. The problem being, as I said, I thought the solutions would be exactly the same, and in a way they are exactly the same. It's just that it makes a difference if you have a 10 element word list versus having a 5,000 element word list. If you have a 5,000 element word list, it makes more sense to iterate through letters, and then do a hash set lookup rather than iterate through 5,000 words. Okay, that's it. Hope you enjoyed it. Feel free to like, subscribe, comment, and see you next time.